Okay, very good morning. Yeah, so if you look back your Google Classrooms and YouTube links, we have explained the first two experiments of part A. Okay, that is S-stable multivibrator using 555 timer IC and as well relaxation oscillator using op-amps. Okay, in continuation with that, we have one more experiments to be done. One more experiment to be done, in fact, that is window comparator. Okay, window comparator. Okay, today I'll be demonstrating the working of window comparator along with the circuit using multisim simulation tool. We can do it. Okay, the question is design and simulate the window comparator using op-amp is the question. Question number 3 of your part A. Okay, so if we just complete this, we will be completing all the 3 experiments of part A, right? Okay, so let's start up the window comparator without any further delay. I'll just brief out what is window comparator. You know what is comparator. There are two types of comparators, inverting comparator, non-inverting comparator. Overall, the definition of comparator is compare. It will compare two signals, that's it. Okay, one is fixed or reference signal, other one is moving signal, which is passing. Okay, so it will compare two signals and generate some output. It will compare two signals and generate some output. That is called as comparator. ಓಕೆ ಸೊ ಜನರಲ್ ಆಗಿ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ ಕಂಪ್ಯಾರೇಟರ್ ಅಂದ್ರೆ ಎರಡು ಸಿಗ್ನಲ್ ಕಂಪೇರ್ ಮಾಡುತ್ತೆ ಅಷ್ಟೇ. ಅದು ಕಂಪೇರ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ಕೊಡುತ್ತೆ. ಔಟ್ಪುಟ್ ಮೇಲೆ ನಾವು ವಿ ಕ್ಯಾನ್ ಡಿಸೈಡ್ ವೆದರ್ ವಿಚ್ ಸಿಗ್ನಲ್ ಇಸ್ ಹೈ ವಿಚ್ ಸಿಗ್ನಲ್ ಇಸ್ ಲೋ ಅಂತ. ಓಕೆ, ಸೊ ಇನ್ವರ್ಟಿಂಗ್ ಕಂಪ್ಯಾರೇಟರ್ ಅಂದ್ರೆ ವಿಚ್ ಇಸ್ ಇನ್ವರ್ಟೆಡ್, ಔಟ್ಪುಟ್ ಇಸ್ ಇನ್ವರ್ಟೆಡ್ ವರ್ಷನ್ ಆಫ್ ಯುವರ್ ಇನ್ಪುಟ್. ನಾನ್ ಇನ್ವರ್ಟೆಡ್ ಕಂಪ್ಯಾರೇಟರ್ ಮೀನ್ಸ್ ಇಟ್ಸ್ ದ ಸೇಮ್ ವರ್ಷನ್. ಓಕೆ, so in along with that inverting and non-inverting, we have one more comparator called as window comparator. Okay, so window comparator is basically the inverting and non-inverting combined together. Okay, window comparator is basically the inverting and non-inverting comparator combined together. So if you look at the window comparator, you will clearly understand what is inverting comparator and as well what is non-inverting comparator. Okay, so the basically window comparator circuit is a mixture of two comparators, which is inverting comparator and as well non-inverting comparator. Okay, okay, so inverting comparator and non-inverting comparator used to give the outputs in the form of high or low. That depends upon the type of input signals what you do. But since this is window comparator, mixture of both inverting and non-inverting, the output detects the input voltage level, whether the input voltage is in between this range or not. And the output will detect the input level, whether the input is between this range or not. And the okay, I'll just give out the explanation briefly. Okay, okay, so first thing you should know is it is basically the inverting and non-inverting comparator which is mixed together. This is the first very important point. Okay, the second is it detects the input voltage level, whether indicating whether a voltage is greater than or less than some prefixed, okay, prefixed voltage point. I'll just show you the circuit diagram, then I think you will understand much better. Okay, the next thing is you'll be having two reference voltage level. Okay, for a pair of voltage comparator you'll be having two reference voltage. I'll show you this. This is also in the circuit itself. Okay, so out of which one reference will give you which is called as V reference upper. Here V reference stands for reference voltage upper point. Okay, where the output should trigger. Okay, and one which triggers at op-amp detection lower is called as V reference lower level. ಓಕೆ, ಸೊ ಎರಡು ಪಾಯಿಂಟ್ ಇರುತ್ತೆ. ಒಂದು ಅಪ್ಪರ್ ಪಾಯಿಂಟ್ ಅಂತ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಮತ್ತೆ ಔಟ್ಪುಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇನ್ನೊಂದು ಲೋಯರ್ ಪಾಯಿಂಟ್ ಅಂತ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಮತ್ತೆ ಔಟ್ಪುಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಆ ಅಪ್ಪರ್ ಮತ್ತೆ ಲೋಯರ್ ಮಧ್ಯೆ ಔಟ್ಪುಟ್ ಸೇಮ್ ಇರುತ್ತೆ, ಅಷ್ಟೇ ಕಾನ್ಸೆಪ್ಟ್ ಇದು. ನೀವು ಎರಡು ಪಾಯಿಂಟ್ ಕೊಡ್ತೀರಾ, ಆ ಎರಡು ಪಾಯಿಂಟ್ ಮಧ್ಯೆ ಔಟ್ಪುಟ್ ಸೇಮ್ ಇರುತ್ತೆ, ಅದು ಅಂದ್ರೆ 1 ಇರುತ್ತೆ. ಎರಡು ಪಾಯಿಂಟ್ಗಿಂತ ಲೋಯರ್ಗಿಂತ ಕಡಿಮೆ ಬಂದ್ರೂ ಅಪ್ಪರ್ಗಿಂತ ಜಾಸ್ತಿ ಹೋದ್ರೂ ಔಟ್ಪುಟ್ 0 ಆಗುತ್ತೆ. ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್. ಇಫ್ ಐ ಟೇಕ್ 1.5 to 3.3, if my input is less than 1.5, output will be high. If my input is greater than if my input is less than 1.5, the output will be low. Okay, if the input is greater than 3.3, still the input is low. But if my input is in between 1.5 and 3.3, here I repeat, if the input is in between 1.3 and 3.3, my output will be high. 1.3 ಗಿಂತ ಕಡಿಮೆ ಬಂದ್ರೂ ಔಟ್ಪುಟ್ 0 ಆಗುತ್ತೆ. 3.3 ಗಿಂತ ಜಾಸ್ತಿ ಹೋದ್ರೂ ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ 0 ಆಗುತ್ತೆ. ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ 1.3ಗೆ ಮತ್ತೆ 3.3ಗೆ ಮಧ್ಯ ಇದ್ರೆ ಔಟ್ಪುಟ್ 1 ಇರುತ್ತೆ, ಹೈ ಇರುತ್ತೆ, ಅಷ್ಟೇ ವಿಂಡೋ. a particular slab baratala, it looks like window, hence it is called as window comparator anta. Okay, it looks like window, it is called as window comparator. I repeat, if the input voltage, I'm taking an example, don't take it very straightforward, I'm just an example. If the input voltage is less than 1.5, output is 0. If the input voltage is greater than 3.3, still the output is 0. Okay, if the input is in between 1.3 to 3.3, output will be 1. Simple. That is called as window. A 1.3 to 3.3 madhya ideyalla, that is called as window. Iga a 1.3 ಅನ್ನೋದು ಕಡಿಮೆ voltage, so it is called as V reference lower. ಇಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ, V reference lower, you can see, right? That is the one which is at the lower, which will trigger at your lower level. The 3.3 which I was telling you, that is called as V reference upper. I can set the value, that depends upon my VCC and my that depends upon my VCC. Okay, that depends upon my VCC. Okay, fine. So hope you got, there will be 2 points. Okay, 2 triggering points. One triggering point is at the lower voltage, which is called as V reference lower. Other triggering point is upper voltage, which is called as V reference upper. If the input voltage is less than V reference lower, output is 0. If the input is greater than the V reference upper, output is 0. If the input is in between V reference lower and V reference upper, output will be high. Done. Our job is done. Okay, fine. So I think we'll be using 4 resistors here, which is of equal values. Okay, the lower voltage is called as 1 by 3 VCC, obviously, because there will be 3 resistors divided by equally 1 by 3 VCC. The upper is 2 by 3 VCC. Okay, fine. So now let's see the working. I think the initial switching condition, this will be given in the manual. Look, when the input voltage is below, look here, very important. When the input voltage is below the lower voltage, V reference lower, which is equal to 1 by 3 VCC, output will be 0. This is first thing. When the input exceeds 1 by 3, okay, the output will be high. That's what I said you. If it is less than 1 by 3, output will be 0. If it is greater than 1 by 3, but less than 2 by 3, it is again, it will be high. As the Vin continues to increase, it passes the upper voltage level. ಅಂದ್ರೆ ಮುಂದಕ್ಕೆ ಹೋಗ್ತಾ ಅಪ್ಪರ್ 2 by 3 ಪಾಸ್ ಆಗುತ್ತೆ. ಆ 2 by 3 ಪಾಸ್ ಆಗ್ಬಿಟ್ರೆ ಮತ್ತೆ ಔಟ್ಪುಟ್ 0 ಆಗ್ಬಿಡುತ್ತೆ. ತುಂಬಾ ಈಸಿ ಇದೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು. ಯು ಶುಡ್ ಬಿ ಏಬಲ್ ಟು have very clear cut point. I'll just show you one more. Okay, I'll just show you writing like this. Let's assume this as a waveform. Okay, let's assume this as a waveform. Yeah, I'll show you with respect to the paint. In paint, I'll just explain this. Okay, look out here. Look this. Let me assume this as my input point. Okay, so this as my input point. Let me say, yeah, I'll just draw a line over here. Okay, let me call this line as 1 by 3 VCC. Let me call this line as 1 by 3 VCC. Let me call this line as 2 by 3 VCC. We call that line as 2 by 3 VCC. Okay, now draw a straight line here. 1 by 3 again, 2 by 3, this is 1 by 3 again here. Okay, once when you draw a straight line here, okay, so output will be 0. Before that, let me have one more color. Yeah, output will be 0 here. Okay, once when the input crosses this point, 1 by 3 VCC, output goes high. Okay, so input keeps on moving up to this point, till that point output will remain high. Okay, once when the input crosses this point, outputs become 0. Okay, so input again reaches this maximum. This is called as VCC point. Let me say VCC is 10 volts. Okay, VCC is 10 volts. Input will be 0. Again output will come up to this point. Okay, This is again 2 by 3 VCC. Okay, till that point output continues to be at 0 only. Okay, once when the output comes below this, once when the input comes below this, output will again go to 1. Okay, so input passes this level, again comes back to this level. Okay, so till that point output will be 1. Once when this point our input crosses that point, again your output will go to 0. Again input will just pass away up to, it will come up to this point. Up to that point, still your output becomes 0 only, still your output becomes 0 only. Okay, only when it crosses that point, output will become again 1. Output will again 1 up to what point? Up to this point. Okay, once up to this point, output will remain 1. Once when this point completes, output will again comes back to 0. And this process is called as window comparator, and this is what is called as window. This is what it is called as window. Okay, fine. Since it will be having 2 level, it is called as, this is called as V reference lower. V reference lower. Okay, and this point is called as V reference upper, because it is upper voltage. V reference upper. This point is called as V reference upper. Okay, that's it. We will be having 2 voltages, lower reference voltage, upper reference voltage. Okay, so what is that reference voltage? I don't know. That depends upon my VCC. If my VCC is 10 volts, okay, let me write here. If my VCC equals 10 volts, okay, I can say 1 by 3 VCC equals 10 by 3, which is equal to 3.33. Okay, 2 by 3 VCC equals 20 divided by 3, which is equal to somewhere around 6.66. Therefore, this is my V reference lower. This is my V reference lower. Okay, so this is my V reference upper. Ashte ಇನ್ನೇನು ಇಲ್ಲ ಇದರಲ್ಲಿ. Okay, VCC ಎಷ್ಟು ಕೊಡ್ತೀವಿ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Okay, so 3.33 ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ ಔಟ್ಪುಟ್ 0 ಇರುತ್ತೆ. 6.6 ಗಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ ಔಟ್ಪುಟ್ 0 ಇರುತ್ತೆ. ಈ 3.33 ಗೂ 6.6 ಗೂ ಮಧ್ಯ ಇತ್ತು ಅಂದ್ರೆ ಔಟ್ಪುಟ್ 1 ಇರುತ್ತೆ. ಅಷ್ಟೇ ಕಾನ್ಸೆಪ್ಟ್ ವಿಂಡೋ. Okay, so that is all the concept of window comparator. All right, okay, let's close this. Okay, that's what I told you here. Look here. Okay, yeah, it compares 2 reference voltages. It detects the input voltage that are within specific band. Specific band andre it is between 3.33 to 6.6. It's specific band. Detect ಮಾಡುತ್ತೆ. Oh, input ಇಷ್ಟೊಳಗಡೆ ಇದೆ ಈಗ ಅಂತ ನನಗೆ ಗೊತ್ತಾಗುತ್ತೆ. Okay, that is how we have to understand this experiment. Okay, fine. Now, yeah, so we need something. I think that is all he has explained very clearly. I think if you understand what I said you on the screen, that is much more than enough. Okay, let's no worry about this. Let's start with the circuit directly. Let's start with circuit directly. Okay, so let me go with the new circuit. Okay, let's, what all we need? We need op amp, and it will be in analog IC. Take the first op amp 741. Okay, place it over here. You need one more, control C and control V. Take 2 op amps. Okay, take 2 op amps and take 4 resistors. In fact, R1, R2, R3 and R. R1, R2, R3, and we need one more R here. We need one more R here. Okay, and we need one VCC. You can take one VCC over here. This is VCC, and obviously you need a ground for any circuit. And op amp, you need dual power supply. Let me have one power supply here. Okay, and let me take the input in the form of sine wave, AC voltage source. Let me take the input in the form of sine wave, AC voltage source here. Okay, I think we are done. I think we are done. Okay, so now click on this, left click, right click, clockwise. It will change to the clockwise so that the connections will be easy for us. Okay, connections are made as like shown in the circuit diagram. Okay, fine. So, yeah, so connect the top resistor to VCC. Connect the top resistor to VCC. Okay, so double click on 5, you can change it to 10. Double click on 5, change it to 10. Okay, this is R2. Okay, just move away. This is the default values of this is 1K. Let it be as such, because you can design for your own choice. Design for your own choice. Okay, fine. Next, see here you can see Vs plus here. You can see Vs plus here. So give that point to plus. Give that point to plus. Okay, and the other one give it to minus. The other point give it to minus. Minus in the sense ground. Minus will be given to ground. Okay. Okay. This is again Vs plus. Okay. Give this to the same plus what you are given there. Okay. Fine. minus is already given to ground, make this as vertical. Okay, so you can see Vs minus here, give this to the minus. Again, this is Vs minus. Okay, so give this point to the minus value, this plus give it to ground. Okay, see how beautifully the circuit looks like now. Okay, how beautifully the circuit looks now. Okay, so you short both the outputs here, and you clockwise create this. Okay, so yeah, give this to VCC, give this to the VCC. Okay, so the other end will be given to the output. This will be taken across your output. I take one cathode ray oscilloscope, let it be as it is right now. Okay, we have to do some more connections here. Short, you see this is inverting. Okay, the first comparison inverting, this is non-inverting. And only plus input ಕೊಡ್ತೇನಲ್ಲ non-inverting input. Only minus input ಕೊಡ್ತೇನಲ್ಲ that is inverting input. Okay, so short here minus and plus, short here minus and plus. Okay, so connect this to the input. Short here minus and plus, connect it to the input. Okay, fine. The other end of the input to the source will be given back to ground. Okay, so connect this pin number 3, this point. Okay, this point. Connect pin number 2 to the next resistor. I'll just text over here. This is 1/3 VCC. This is 1/3 VCC. Okay, according to this, it is 10/3, which is equal to 3.33. Okay, that is my lower reference. Illa artha agbidutte ninge. Okay, yav voltage ಏನು ಆಗಬೇಕು ಅಂತ 10/3 volts. Okay, fine. When I come back here, place this text over here. This is 2/3 VCC, which is equal to 10 to the 20, 20/3. Sorry, 20 divided by 3, which is equal to somewhere around 6.66 volts. Somewhere around 6.66 volts. That is this point. Okay, so this is that point. Andre iga 3.3 ginta kadime ittandre output 0 irutte. Okay, 3.3 ginta ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ output 1 ಆಗುತ್ತೆ. 6.6 ತನಕನೂ 1 ಇರುತ್ತೆ. 6.6 ಆದ್ರೆ ಮತ್ತೆ 0 ಆಗುತ್ತೆ. ಅಂದ್ರೆ 3.3 ಮಧ್ಯೆ 6.66 ಮಧ್ಯೆ output 1 ಇರುತ್ತೆ. ಮಿಕ್ಕಿದ್ದೆಲ್ಲ 0 ಇರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಓಕೆ, ನಿಮ್ಮ ರೆಫರೆನ್ಸ್ ವೋಲ್ಟೇಜ್ ಇಲ್ಲಿ 6.3 ಇರೋದ್ರಿಂದ ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ 1 ಗಿಂತ ಜಾಸ್ತಿ ಕೊಡಬೇಕು. ನೀವು 1 ವೋಲ್ಟೇಜ್ ಅಷ್ಟು ಹೋಗೋದೇ ಇಲ್ವಲ್ಲ ಅದು. ಸೊ ಗಿವ್ ಅರೌಂಡ್ 10 volts. It's enough. Give around 10 volts. Okay, that should be enough. Okay, now let's see whether we get the output or not. Let's run. Okay, sorry, before running I have to make the connection of the output. This give it to the input part so that I can visualize the input signal also. Connect this to the input part. Connect B to the output part here. Connect B to take one more ground because the line will be very high here. It will be lengthy. Connect this ground to the ground. Connect this ground to the ground. Right? Okay. So now run the program. Let's see. Elaborate this. Yeah, you are getting, no doubt. Okay, so yeah, let me pause this. Let me change the Y position level. Just open one more circuit. Yeah, this is what I have written. Okay, let's run. Same connection, let's run. Okay. Yeah, look at the waveform, perfect waveform. Okay, perfect waveform we are getting. This is window. Now what I will do, I have two measuring instrument here. Okay, so one measuring instrument you keep at this point. Other, no, what I am trying to say here is this input is going like this. Okay, this is the point where it crosses V reference lower. ಅಲ್ಲಿವರೆಗೂ ಔಟ್ಪುಟ್ 0 ಇದೆ. ದಿಸ್ ಇಸ್ ಔಟ್ಪುಟ್. ಇದು 0 ಮಾಡೋಣ. ಓಕೆ, ಇದು ಇನ್ಪುಟ್ ವೇವ್ ಫಾರ್ಮ್. ಇನ್ಪುಟ್ 0 ಮಾಡಿದ್ರೆ ಔಟ್ಪುಟ್ ಮಾತ್ರ ಎ ಸಿ ಕೊಡಿ, ಔಟ್ಪುಟ್ ಕಾಣುತ್ತೆ. ಆಯ್ತಾ? ಈಗ ನೋಡಿ, ಔಟ್ಪುಟ್ ಇದೆಲ್ಲ 0 ಇದೆ. ದಿಸ್ ಪಾಯಿಂಟ್, ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪೋರ್ಷನ್ ಆಫ್ ದ ಔಟ್ಪುಟ್ ಆರ್ ಆಲ್ 0. Okay, this is the particular portion of output where it is considered as to be as 1. Okay, now I'll just make this output is 0. I'll make only the input. Okay, measure the input. You take this measuring instrument, you move along with this. You can see this. You can see 10 volts here. 10 and minus 9.6. That is okay. My plus 10 minus 10 wobbling the swing agatadu. Okay, since I'm giving VCC as 10 volts here, obviously this should be my 10 volts. I'm getting that value here. So I'll make this output also as AC. Nodi ishtu chennagi bantu nodi. Okay, so till this point, output is 0. Once after crossing the output, after crossing that particular point of input, output becomes 1. Up to this point, again output becomes 0. Up to what point? Again till up to this point. Matte rise agbeku. Okay, matte illivargu 1 irutte, matte 0 agutte. So this is window. Okay, keep it like this. Measure this. Measure. Okay, what is that you are getting here? You are getting 3.6 here. Look here, VA2. Look at this VA2, 3.6 volts. Perfect. We are supposed to get 3.6 only, right? Getting suppose 3.6. Atatra ashte barta ide. Okay, so measure this. 7.2. We are supposed to get somewhere around 6.66. Okay, but I think, yeah, let me arrange. Yeah, 6 badlu I'm getting around 7 to 7.2. Let me be more clear. This is the point where it's coinciding. Yeah, it's 7. So instead of 6.6, I'm getting it as 7. Look at the same point. So it is in between 3.6 and 6.6. Output is 1. If it is less than 3.6 or greater than 6.6, output is going to be 0. This particular portion is called as window. Hence it performs comparator of two values. It is called as window comparator. This is inverting comparator. This is non-inverting comparator because input is given to the plus point here. Hence it is non-inverting comparator. Since input is given to the minus here, this is inverting comparator. So for window comparator, is a mixture of both inverting as well as non-inverting comparator. Okay, I hope you have understood. Here we complete all the 3 experiments of part A. Okay, so any doubts you can just ask me, or else when you come back to the classes for physical classes, to the labs, you can just keep this video with yourself and you can start practicing. Okay, that's all. Nothing to measure, no calculation, nothing. Okay, calculations I'll teach you sometimes else. It's all equal calculations what you need. But the only thing is you need to know how to measure the outputs. You need to write the circuit in the examination. You need to write this waveform. You need to mention what all I have mentioned in the paint. Okay, the paint I have mentioned few things. Those things completely should be written on your paper in the examination. Okay, then only it is acceptable. Okay, fine. Thank you. Thanks for watching.